Okay, so we're going to do some more examples, especially using compositions of more than just two functions. First, I wanted to point out that there's a typo here. This really should have been, here we go, I'll just cross this out. It should have been this whole thing, x squared plus 5x to the power 100. So I'll fix that on the PDF that I upload, but just so you know. Okay, so let's start at A. We just want to differentiate this function, and notice that I'm going to actually rewrite this as cosine of x to the fifth to the power 3, right? Because that's what this notation means when the 3 is right next to the cosine. And so then it's easier to see that we have three functions combined or composed together, right? So our first outside function, I'm not sure what I'm going to call the other ones, but okay, we have an outside function, inside function, which would be cosine, and then, I don't know, we'll call this inside squared. No, maybe that would be confusing. Inside function. That will be x to the fifth. Okay. So it gets kind of tedious when you start trying to list out the outside and inside functions when you have more complicated functions like this. So I'll probably drop this for the next few examples. But you can still do this if you're not yet comfortable with figuring out what is the outside function and inside function by just looking at the function. Okay, so we take the derivative. So the biggest thing going on is this power of 3. So we can use the power rule on that, and that would be 3. And then we would leave this whatever's inside alone. So that's cosine of x to the fifth. And then the power rule, we decrease the power by 1. Okay, I'm actually gonna move this down so I don't run out of room. Oh, oops, that always happens. Okay, here we go. Okay, so that's the first piece, the first derivative, and then we need the derivative of the next function in the composition, and so that's going to be the cosine. So the derivative of cosine is negative sine, and then we keep that x to the fifth inside, right? And then the last piece is the derivative of x to the fifth. So that's just 5x to the fourth. So we're always moving from the outside in when we're using the chain rule. And so we had this kind of, from the outside in. So this is similar to when we were dealing with limits. We were kind of moving from the outside in when we were applying limit laws. And the thing, and it works the same way with derivatives. So usually you want to look at a function, you want to determine what is the biggest thing going on, and then move in from there until you reach like the most basic part, right? Okay, so we have this next function. And so I'm going to do this without labeling each of the functions. So when I look at this function, I see e to this stuff in the exponent. And I know that e to the x, the derivative of that is e to the x. So my first derivative is going to be e to the stuff in the exponent. So just tangent of cosine of z cubed. Okay? So that's my first derivative. My next thing, the next largest thing going on is this tangent. So the derivative of tangent is secant squared, right? And then what's inside of the tangent, I keep that inside of my derivative. So cosine of z cubed, right? And then I have cosine, that's the next biggest thing. And cosine, the derivative is negative sine. So negative sine, and then I keep the z cubed inside. And then now we're down to the final piece, and that's z cubed, and the derivative is 3z squared, right? So, yeah, so this would be 4 functions. So we had 4 pieces in our derivative. Okay, and now I'm going to do some examples that involve combining functions. I think we had a little bit of practice at this in the in-class work, but just to have some extra examples. Notice here that I have this this fraction being taken to the power 3. So I have a function inside of the x cubed function. So I need to use a chain rule, and then also I have a ratio of 2 functions, so I'm going to use the quotient rule on that. So that's what's necessary for this problem. And so I'm going to start by using the chain rule, because that's what's going on the outside. And then when I get to having to take the derivative of this part, that's when I'm going to use the quotient rule. So we get 3, we leave the inside alone, and then we decrease the power by 1, so we get 2, so this squared. And then we want to compute the derivative of x plus 1 over x minus 5, right? Okay, so now I use the quotient rule, so let's copy down what we had before, and then we start by taking the derivative of the numerator, that's just 1 times the denominator, minus the derivative of the denominator, which is just 1 times the numerator, plus 1, and then over denominator squared. Okay, and I could simplify this a bit, but okay, why not? We have a 3. This would simplify to, so the numerator would be x minus 5 minus x minus 1, so it'd be negative 6, right? And then I would get, so I get 3 times negative 6, which is negative 18, times x plus 1 over x minus 5 cubed. Okay, so that would be your answer. Now here in this next example, just looking at this function, I have, so hopefully that's not too distracting, maybe I'll just wait this out. Okay, so I have sine squared of x, and then this x squared plus 5x to the power 100. So I have 2 functions being multiplied together, and that's sort of the largest thing going on. So I need to first use the product rule on those 2 separate functions, and then when I look at each of these functions, they are compositions of 2 functions, so I'll have to use the chain rule on each of them. Okay, so product and chain rule is what we're going to use. And so let's start off with the product rule. So first we might start with the derivative of sine squared of x. And I'm not yet computing that because I know that I need to use the chain rule on that. And then we'll have plus sine squared x times the derivative of this piece to the power 100. Okay, so first I have, this is one I think we did in class, so the first, or the outer function is x squared, so it's the variable being squared, and then the inner function is sine. So first we do 2 times sine x, that would be to the power 1, but we don't need to write that part, and then the derivative of sine x is cosine x. Maybe to have less parentheses, I'll just, yeah. Okay, so that's the derivative, and then we still have to have this piece, but okay, and then we want to take the derivative of this second part. So first we have the we want to use the power rule, so that would be 100 to x squared plus 5x to the 99. So that's the power rule on that outer function, and then we multiply that by, unfortunately I don't have enough room. I think I'm going to cheat and move this over. Okay, yeah, I should be able to squeeze it in now. So that would be 2x plus 5 for the derivative of the inside function. Okay. Yeah, so that's that. And then in this last example, there are sort of two options. You could either use the chain rule, and I'll show you how to do that, or you could use the quotient rule. And personally, I prefer the chain rule, but we'll do both ways so that you can see both. So first, if I want to use chain, I would rewrite this as 3x minus 5 to the negative 2. So bringing that up into the numerator by making this a negative exponent. And then you see that your outside function is this x to the negative 2, and the inside function is the 3x minus 5. So the derivative of this would be the derivative of the outside function. So using the power rule, we have negative 2, 3x minus 5 to the negative 3. That's the derivative of the outside function times the derivative of the inside, which is just 3. Right? So we could rewrite this as negative 6 over 3x minus 5 cubed. Right? And then the other option is to use the quotient rule. And so it's already in a form where we can use the quotient rule, so we would just go ahead and apply that. So we would start with the derivative of the numerator. So remember that the derivative of 1 is going to be 0 because that's the derivative of a constant, right? So maybe to make this clear, all right, derivative of 1 times 3x minus 5 squared minus, we would have 1 times the derivative of the 3x minus 5 squared, and then we still have to use the chain rule on this, right, because we have an inside and outside function. So it would be 2 3x minus 5 to the power 1, right? Okay, and then don't forget to put the whole thing over the denominator squared. Okay, so we can do some simplification. Remember, this is just 0, so this whole term is going to disappear, right? And then we'll be left with negative 2 times 3x minus 5 over, if we combine these exponents on the 3x minus 5 in the denominator, we get 3x minus 5 cubed. Oh, looks like I forgot, yeah. So we should definitely get the same answer. And I forgot the second part of my chain rule. So we did the derivative of the outside function and didn't do the derivative of the inside function. That's just 3, right? Okay, so what we'll get when we simplify now is negative 6 times 3x minus 5 over 3x minus 5 to the 4th, and then that simplifies to the same thing that we got before, so 3x minus 5 cubed. So I do think that the chain rule is a lot easier in this case, and also it can be easy to forget that the derivative of a constant is 0. I mean, you shouldn't forget that, but it can be a point where maybe this will trip you up. So I would say use the chain rule if you can. Rewrite a quotient like this, So just be on the lookout for that. Okay, so don't forget to answer the comprehension check question.